Just kind of waiting for everybody to get in. There's a couple missing yet, I believe. All right, I think that's everybody. Awesome, very good. All right, we're well, we should have the quiz in by now, hopefully, and I think you all do. And we are off to. Let me make sure. I gotta look at one thing real quick. I'm looking at our schedule here. What's today? The 8th. Yep, I just want to make sure I had the right topic up. I do. Hopefully, you looked at velocity, speed, and acceleration yesterday. Make sure you get that those two for your response taken care of. Let me know if I haven't put a spot in Google Classroom for that. I can see myself forgetting that occasionally, hopefully not. But all right, so our next topic is tangent lines, average rate of change, mins and maxes. So I'm going to share the screen and we'll get going here. All right, we have, where's my cursor? Where'd it go? There we go. A non-calculator problem to start out with. Consider the function f of x equals 1 over x squared minus kx. So notice I got that k in there, where k is a non-zero constant. The derivative of f given by, so they give us the derivative. We probably could have figured that out on our own, but they give it. Or chat. From what I can tell you, I've not put a post for the velocity assignment on Google Classroom. Okay, I will. Thanks for letting me know for the velocity one. Oh, so I need a spot for that. I'll get that up there. Thanks for letting me know. Let k equal 3 so they put 3 in for k there. Write an equation for the line tangent to the graph of f at the point whose coordinate is 4. So write an equation for the line tangent. So we need a point and we need a slope because we're writing a tangent line just like any other time. So the x coordinate, ooh, how'd that pop up? Oh, I think I hit my mouse. The x coordinate is 4. And if we plug 4 in here, we get, what do we get? I'll put it over here. F of 4 is equal to 1 over 16 minus, and I guess I'm plugging it in here. 4 times 3 is 12, so 1/4. So 1/4. The slope, we're going to plug 4 in for the x. So f prime of 4. K is 3. So 3 minus 8, because we plugged 4 in for x, over 16 minus, someone needs to come in. There we go. 16 minus, what is that? 3 times 16 minus 12 down here. So that's -5 over, let's see, 4 squared, 16. -5/16 is what I'm getting. -5/16. So on letter A, we got y minus 1/4 equals -5/16 times x minus 4. Is that all I need to do? Write the equation? That's it. All right, on to letter B. Let k equal 4, thus that f of x is equal to, so they plug 4 in for k up there. Determine whether f has a relative min, max, or neither at x equals 2. So let's do f prime of 4. So f prime of 4 is, let's see, they have k is 4. Oh no, f prime of 2, excuse me, f prime of 2, we're plugging 2 in for x. There we go. So 4 minus 4, well, that's going to be 0, unless the denominator is 0, but I don't think it is. If we plug 2 in for x, we get 4 minus 8, because k is 4, x is 2. So that's going to be 0. So now we know we have a potential minimum or maximum here. F prime of 1 is equal to, what's our k? K is 4. So 4 minus 2 over, and if we're squaring the denominator, it's not going to affect the value, whether it's positive or negative, but well, let's continue on anyway. 4 minus 8 squared. So that's 2 over 16, 1/8. But more importantly, that is positive. F prime of 3 on the other side of 2 is equal to 4 minus 6 over x is 3, 9 minus 12. That's going to be negative 2 over, that's going to be squared, negative 2/9, which is less than 0. So the derivative goes from positive to negative. So a relative maximum at x equals 2. How do I know that? F prime changes from positive to negative. What was letter, what was that? That was the letter B. Letter C, find the value of k for which f has a critical point at x equals -5. Well, that means I want f prime to be 0 if there's going to be a critical value at -5. So f prime of x is equal to some k minus 2 times -5, because the x is -5 here, over, I mean, it doesn't even really matter here, just as long as the value that I find doesn't make the bottom 0. 25 minus k times -5. But I don't even really care about the denominator. I just need the numerator to be 0. So 0 is equal to k plus 10. It's going to be plus 10. So k negative 10. And if I put a negative 10 down there, that's not going to make the denominator 0. So we're good. Letter D. Let k equal 6 so that f of x is equal to 1 over x squared minus 6. So they put a 6 in for k. Find the partial fraction decomposition for the function f. All right. And then find the integral. 1 over x squared minus 6x. Let's factor out an x. That's x minus 6 is equal to a over x plus b over x minus 6. So we're doing the partial fraction decomposition for this. Well, now I have to get common denominators. So we're going to multiply this by x minus 6 on the top and the bottom, and this by x on the top and the bottom, and then would have all the same denominators. 1 is equal to a times x minus 6, curve, plus bx. Now we're going to let x equal 6. We're going to make this factor 0. So that's 6b. So b is 1/6. And then we'll let x equal 0. And we get 1 is equal to negative 6a. We're going to make this one 0 over here. So a is negative 1/6. Now I like the second one to be negative. I don't like the first one to be negative if we can help it. So this is the integral of negative 1/6 is the a, so we'll put the 1/6 first. That's 1 over 6 times x minus 6. And then minus 1 over 6x dx. So we can factor a 1/6 out. That's going to be the natural log of absolute value of x minus 6 minus natural log of absolute value of x, and then plus c. So 1/6 natural log of absolute value of x minus 6 over x. Remember, when you subtract logs, you can combine them as a division and then plus C. And I think that's how the rubric has the answer. All right, let me know if you need to go back. Let me know in the chat. Here is the rubric for it. There's they kind of they added the 1/4 over. F prime changes from positive negative relative maximum. There's the -10. Here's the work for the partial fraction decomposition down there, and you can kind of look back and see the points if you'd like. All right, how about a calculator problem? Grass clippings are placed in a bin where they decompose. For 0 to 30, the amount of grass clippings remaining in the bin is modeled by A of t, where A of t is measured in pounds and t is measured in days. Find the average rate of change of A of t over the interval 0 to 30, indicate units of measurement. So for part A, we want A of 30 minus A of 0 over 30 minus 0. Average rate of change is old school slope. Y2 minus Y1 over X2 minus X1. So A of 30. So 6.687 times 0.931 raised to the 30th power. So 0.78, 0.7829, keep on going, minus A of 0, well, that'll be 1. So that's going to be 0.6 or 6.687, and we're going to divide that by 30. So we're going to minus 6.687 and then divide that by 30, and we get that value right there. So negative 0.196 or 0.197. Let's check that, make sure I did that right. Yep, looks right. Do I need using correct units? Indicate units of measurement. And that's the average of rate of change of this. So that's going to be pounds per day. Pounds per day. There we go. B, find the value of A prime 15. Using correct units, interpret the mean of the value in the context of the problem. Let's find A prime of 15. A prime of 15 is equal to, and we have math number 8 to find a derivative. If we can use a calculator, we're going to use a calculator, but we're going to mark down what we're actually doing here. So 6.687 times 0.931 raised to the x, and then we're where are we at 15. So negative 0.163 or 0.164. Let's look at what they have for the answer for that. There's the value, but it says the amount of grass clippings in the bin is decreasing. So the amount is decreasing at a rate of 0.164 pounds per day at time t equals 15. You know, it's important to say this is happening at t equals 15 because this number is specific to this value. So if you didn't put t equals 15, I don't know if you get the point or not. Notice that also that if they say decreasing, then they're not reporting this as a negative value. If you said instead of decreasing, you said changing, then you would have to have this as a negative. So be careful with how you, what words you use with the values that you use. And if you said decreasing at a negative value, then you may not have it because now you're indicating that it's actually increasing because you're reversing it with that negative. So be careful in that situation. Letter C, find the time t for which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin over the interval 0 to 30. So we want an average value of A of t. So that's 1 over B minus A integral from 0 to 30 of a of t dt. So we're going to go math number 9, 0 to 30 of this function. I know the calculator part's a little tedious. Times 0.931 raised to the x or the t with respect to x. So 82.579 for which of the amount of grass has been average. What would the label be on that? Label would be, they don't even have a label. Okay. I think it's just grass clippings, I guess. Pounds, something like that. Pounds, I suppose. Letter C. For t greater than 30, L of t, the linear approximation to A at t equal 3 is a better model for the amount of grass clippings remaining in the bin. Whenever you see linear approximation, it's tangent line. That's all it means. It's just a fancy terminology for tangent line. Use L of t to predict the time in which there will be 0.5 pounds of grass. Okay. Okay, do you have to set... Oh, was it the wrong answer? Oh, what? How come I got a different answer? Unmute all. Let's see what kind of background noise we have. Sounds pretty good, you guys. Do you have to set equal to A of t? Is that what it is? Find the time t for the amount of grass clippings has been is equal to... Oh, yeah. So now you're exactly right. You guys are better at this than I am. So now we set 6.687.931 to the t equal to that average amount because we're finding time.
I think you forgot to divide by 30.
Oh, I didn't even divide by 30. Okay. You're right. Divide by 30. So now it's equal to 2.7526. Keep on going. It's not even that right there. 2.7526. So now what are we going to do? We're going to divide by 6.687. So we get that. So 0.931 to the t is equal to this 0.411. Take the natural log of both sides. Equals natural log of 0.411. And then do a little division. So natural log of answer divided by natural log of... Oh, it is exactly 0.931. Boom, we got it. Thanks for your help. I appreciate it. This is getting to be just like class more and more. where you guys are bailing me out on this stuff. Very good. That's letter C. Letter D. The linear approximation. So I need A of at t equals A of 30. Here, let's speed it up a little bit. What time is it? 34. We do have time though. So I need A of 30 and A prime of 30. We can do this on the calculator. We got time. So 6.687 times 0.931. We're going to raise that to the 30th power and get an answer. So there's the point, 0.7829. Keep on going. I'll use the values in the calculator. And then we need A prime of 30, because whenever I see linear approximation, I think I'm finding tangent line. Did I do the derivative up here? Didn't I already do that? Can we save some time? There we go, right here. And instead of 15, I'm doing this at 30. So this is math number 8. This is finding a value of a derivative. So this is negative 0.0559. So now we have y minus that 0.7829 is equal to negative 0.0559 times x minus 30. But now what do we want? We want to predict the time at which there will be 0.5 pounds of grass clippings remaining in the bin. Wasn't that y? So 0.5 minus 0.7829 negative 0.0559 x minus 30. So I have 0.5 minus this value up here. So let's go grab that. Divided by this number right here. That is up here, all right? Yep. And then, so now I have x minus 30 equals 5.0544, keep on going. So we just have to add 30 to that. I don't think I need a calculator for that, but I already hit it. So the time is 35.054. Let's check that. There we go, 35.054. I actually got one all by myself. Any questions on that one? I guess the big takeaway from D, like I've already said, is linear approximation means tangent line. All right, 36. We got 9 minutes to try to slam one more in. And then I'll put that assignment on Google Classroom. I'm glad I mentioned it. Anytime you see it missing, just shoot me an email and say, hey, ding dong, you forgot it. All right, let's try to get this one in here. No calculator. The figure above or off to the right shows the graph of f prime, the derivative of twice differentiable function on the closed interval 0 to 8. The graph of f prime is horizontal tangent lines at x equals 1, 3, and 5, saying that those are actually where the mins and maxes are of f prime. The areas of the regions between the graph of f prime and the x-axis are labeled in the figure. The function f is defined for all real numbers and satisfies f of 8 is equal to 4. There's your initial value. That allows us to get all the other values. So find all values of x in the open interval. Don't include 0, don't include 8, for which the function f has a local minimum. Justify your answer. So local min at x equals over here 1, 2, 3, 4, 5, 6, because the derivative is going from negative to positive. I think that's x equals 6. F prime changes from negative to positive. Determine the absolute minimum value of f on the closed interval from 0 to 8. Now we're include 0 and include 8. Justify your answer. Absolute minimum value. So let's do f of 0 because it's an endpoint. Remember, mins and maxes can happen at endpoints. The only value we have is over here at 8. F of 8 is equal to 4. So we're going to go 4. We can think of this like this, and we're going to subtract out the integral from 0 to 8 of f prime dx, because we're going to go backwards. We're starting at the very right end point and we're going backwards. So we want to actually subtract these values to get back to 0. So that's equal to 4 minus 7. So we're subtracting 7. Remember, this is a negative 3. So that'll actually be plus 3. Minus 6, because that'll be positive. And then minus this area, which is 2. So we're going to minus 2. So that's negative 3, 0, negative 6, minus 2. That's actually negative 8. So f of 0 turned out to be negative 8. How about f of 6 is a local minimum, but it could be the overall minimum also. We're going to start with 4, but all we have to do is just minus 7 on that one. Minus 7 when we're back to that 6. So that's negative 3. So far, negative 8 is the lowest value. And then we have the other endpoint, f of 8, and they just tell us that. That's the initial value. They just say that it's 4. So minimum value is negative 8. Now, it happens at 0, but they don't ask for that. They just say, what is the minimum value? Justify your answer. I think I've shown enough work to have a pretty good justification there. Remember, not all justifications are, you have to write words. Some of it's work. C, how am I doing? 5 minutes. On what open intervals contained in 0 to 8 is the graph of f both concave down Now we could say that for concave down, the second derivative is negative, but we really don't have the second derivative. We only have the first derivative. So we want to know where the first derivative is decreasing. If the first derivative is decreasing, we know the second derivative is negative. And where the function is increasing is where f prime is positive. So we want to know where that's happening. Explain your reasoning. Open intervals contain concave down and increasing. So let's see. I need to know where f prime is positive. That's 0 to 1 and decreasing. From 0 to 1, f prime is positive and decreasing. Then it goes to increasing and decreasing again, but I can only count it from 3 to 4. From 4 to 5, it's still decreasing, but it's not positive anymore. So union with 3 to 4. How do I know that? F prime is greater than 0 and f prime is decreasing. I am continually impressed in the opposite direction at how many people still use the word it on their free response questions. It is shocking how many people are still using it. And it's not a lot, but how many times do I have to mention it? I mean, really, come on, you guys. Don't use, notice I didn't use the word it. F prime, be specific. Don't take chances, especially this year when it's only 2 free response questions. That's all you get. That's all they're basing your grade on. Don't use the word it. Don't give them a reason to take any points off. All right, I got one left. The function g is defined by that. If f of 3 is negative 5 halves, find the slope of the line tangent to the graph of g at x equals 3. So slope of the line tangent. We want the derivative. So this is a pure exercise in the chain rule. So we have 3 f of x squared. So bring that down, reduce it by 1, leave the inside alone, and then multiply by the derivative of the inside. Now we want g prime of 3. So 3f of 3 squared times f prime of 3. So I need f of 3, f of 3. Where's f of 3? Oh, they tell me that. I'm like, I don't remember doing f of 3. They just literally tell us that. I like that. There's a negative 5f. F prime of 3 is up here. That's in the graph. F prime of 3 is 4, so times 4. So how about 325 fourths times 4? We could probably just cancel those out. 3 times 25 is 75. So the answer is 75. All right, I had to hustle, but we got it all in. I have this recorded not just here on Zoom, but I recorded it earlier today, posted on my website. So continue to refresh my page so you get the most current version. So you could either, I'll post this as well if you want to go back and look at those again. On the AP test, you get a choice of taking AB or BC. If you take BC, you don't get a sub-score this year because of the limited amount of questions that they're going to have on the test. So I imagine the 2 tests are going to be completely different. Usually AB and BC share 3 free response and about 20 of the multiple choice. You would get a BC score and an AB sub-score. Obviously, everything has changed because of what's going on. So I'm going to send out a Google form document to you guys probably sometime today so that you can, the counselors need to know or they would like to know which one you're taking. And maybe they have to report that to what's called the College Board, which takes care of all this stuff. So when I send you the email, it's only a 1-question form. Well, it's going to ask your name and whether you plan on taking AB or BC. I'm not going to tell you which one. You can ask my opinion if you'd like, but it's really up to you guys whether you take AB or BC this year, given the circumstances. And then that's completely up to you. So if you want to discuss it with your parents, if you want to discuss it with me, that's fine. I'll give you my opinion, but ultimately it's going to be your decision what you take this year. When we take the AB test, will we only get the AB credit? Yep, that's right. If you take that's what I'm guessing. If you only take the AB, that's what you get credit for. Any questions, you guys? Anything for the good of the cause? I'll throw those assignments up in Google Classroom. Like I said, I'm dang it. I wish I wouldn't forget that stuff, but apparently I did. So get 2 free response done from yesterday and from today. I'll have 1 for Monday. If you want to get that done early, you know, you got 4 days if you want to get stuff done early, if you'd like. Maybe I'll throw the assignment up in Google Classroom for all 3 of those. And then we have another quiz, I believe, on Tuesday. All right, that's my time. Any questions? Have a great weekend. You know, go for a walk, keep social distancing, get outside, try to have a little bit of fun, and we'll see you again on Monday. Bye-bye. I'll see you guys.
See you, Smith.
All right, bye-bye.